Hi and welcome to another video from AI Sciences. In this video, we are going to explore face detection using OpenCV. I'm your instructor Muhammad Ahmad from AI Sciences, and in this video, we are going to see how we can detect the face inside an image and then how we can actually compare the two faces and verify that whether the two images are referring to the same person or not. If you are new to our channel, then just a brief introduction of the AI Sciences that at the platform of AI Sciences, we are providing a lot of services regarding artificial intelligence and data science, including courses, including consultancies and on-demand software development, product development and whatnot. If you are interested in any of this, then do visit links present in the description. So let's just begin. Now, before moving further for the hands-on, I just want to spare some minutes to develop the understanding of what's happening inside this fake recognition model. So the basic idea is that the basic steps that includes in extracting all the information from the image, that what objects to be considered as faces, and what are the prime attributes or prime features of that face to extract from the image, and then how we can actually compare it, that if we want to check that whether the same person is available in two different images, then how we can check that. So first look at a picture and find all the faces in it. So how actually this works is that initially it takes the image and then it recognizes all the faces inside the image. Then second, it will focus on each face and be able to understand then that even if a face is turned into a weird direction or in bad lighting, it is still the same person. So here it uses some shear transformation. If you are familiar with the concept of linear algebra, then you must know that what I'm talking about here, that there are some shear transformations that actually helps us in transforming the image, and usually the image that we consider is considered as the front face image that has all the specs and all the information of the image clearly mentioned. But let's just imagine that if the person is just staring at some other direction, his face is tilted. In that case, we have to first, although we don't actually do that, but under the hood, the module will consider that image, consider rotating it or consider doing shear transformation on it to map it just exactly the same way as of any straightforward picture. After that, it will be able to pick out unique features of the face that you can use to tell it apart from other people, like how big the eyes are, how long the face is, and what is the distance between eyes, and what's the length of the nose. Anything could be extracted, any feature could be extracted for marking the particular face and marking it that this particular characteristics or this particular figures will represent this particular face. Then the first thing is that the step one, now it is explaining it is explaining all this in much more detail. So here it is stating that finding all the faces, so it takes all the images and then using some under the hood HOG or HOG algorithm, it will extract all the faces present inside the image. Then after extracting the image, we usually go for converting it into black, and again I am using the terminology we, but we don't really do it on our own. It's all been done by the library, it's all been done by the module. We just have to call the relevant functions. So after that, the library under the hood converts these images into black and white or grayscale, because we are not interested in any sort of images, in any sort of colors inside the images. Next is the module will just then look for the gradients, look for the pixels, and then it will look for the gradient descent of any color. So here, if you can see that this is a randomly collected pixel, and then it will look for the direction in which the colors are getting darker. So moreover, after completion, we will get something like that. But the arrows actually, if you can see that this is one direction arrow, and if we go further and further, there will be numerous arrows. So the solution for that is that we usually refer to a 16 by 16 grid, and inside that we look for the trend of the colors, and then we assign a single arrow or the most strong arrow, most strong direction to that grid, so that we uniquely identify that position. Next is, after doing that, we are good with detecting the faces. We just look for the common attributes present inside the human face, and then we just recognize for the image, recognize for the face inside the image. Next is that posing and projecting faces. So here you can see that this person is actually just staring at this stem, at this straightforward, and over here it's just a tilted. So this one will, the next step would be doing the shear transformation, that initially it will look for all the marks or the points present on side the face, and then it will apply the transformation to make this image tilted towards straight. So here, if we just go down, so right now you can see that this person is being tilted a little bit, and eventually after applying transformation, shear transformation, this person is now being considered, not literally, but still it's better than this one. Now it's person is considered to be looking forward. Then the third step is encoding the faces. In encoding the faces, we actually have around 128 points in which we recognize the, or we extract the particular features of inside the face. So here you can see that if you can actually observe it, that here inside this face it is collecting multiple information, that the distance between the eyes, or the distance between the nose, the length of the nose and the ear, and a multiple feature it is extracting, multiple figures it is extracting, and then based on that it will develop a concrete figures of particular information. Then next we have, after getting all this information, we just go for getting out the encodings, and then we can just compare those encoding to check that whether the two images contains the same person or not. So let's just do some hands-on with that now. For the hands-on, I am not using any PyCharm or any IDE because there are some installation and there are some version conflicts. So we are using Google Colab, and for that you just need to sign into your Gmail account and go for your drive, G Drive, and just create a folder for the sake of simplicity. Click on the right click on it, go for more, and here you will get the option of Google Collaboratory. Just click on it, and there you go. We have a notebook prepared. It's just like a typical Jupyter notebook, so you can use any language, anything inside it. It totally depends on you. So it's a face detection, and now let's just write a simple Python hello world code just to make sure that everything is running fine. So here it is, it's working perfectly fine. We are getting the output. Next is that we have to just do some imports first, and then we will start writing our code. Before importing, we have to specify the path from which we want to read the data, or we have to upload the files inside this directory so that we can refer to them. So for that, just click on this and go for upload. So for the sake of this example, I'm using 3 images. The 2 is of Elon Musk and the third one is for Donald Trump. Let's just select these and click on open, and it will just upload these images, and we will be able to work on it inside this. So we are getting these 2 images, and we are getting the Donald 1 image. So Elon 1, Elon 2, and Donald 1. Now the first thing is we have to do some imports for making this code work properly, and we have to go for just put this statement so that it will know that we are going to run a command. Then go for sudo apt install cmake, give it a go, and actually for running that you can go for shift enter if you want to just hit it and go for the next one, otherwise just go for control enter. The last one is pip install face recognition. Just give it a go. Yes, that's it. We get the installations done, and let's just now start working on the code. So the first thing is we obviously have to do some imports, and first and foremost would be the CV2, and then we have to go for import face recognition. Just give it a go. Just try to make sure that you put all your imports in one cell. So if you have to just import anything in the later video or at the later time, you just go for selecting or adding the library, adding the import there, and it will work fine. Now here, for some of you it might work fine, but some of you will get the exception that no CUDA capable device is detected. So for that, go for runtime and select for change runtime type, and here we have to select the hardware as GPU. Now click on save, and now if we run it again, so both of them are now importing perfectly fine. We have CV2 and we have face recognition. Also, we have to import one additional thing, because if you are working with the Google Colab, then you cannot go for cv2.imshow for getting the image, and for making the image display inside this Google Colab environment, we have to go for importing from google.colab.patches import cv2 underscore imshow. So if we give it a go one more time, all thing went fine. Next thing is we have to actually start reading the image for us person, and then we will verify that whether for the new image our program is uniquely identifying that or not. So for the sake of this video, we are going to explore the actually when I change that to GPU, it somehow managed to just remove the images. So let's just import it again, and make sure that if you are going to work on the Google Colab, then you just change the GPU first and then you move for uploading the images. Now what we will do, we will consider working for the Alon 1, or we will look for the Alon 1 image, and we will extract the image features for the Elon Musk, and then again we will put the images for Donald and the Elon, another image of Elon, and then we will check that whether we are getting true or whether our code is able to recognize the person inside the image or not. So the first thing is we have to go for let's just consider the Elon image and make it go for face recognition. Inside this face recognition, we have to go for dot load image, and inside that we have to provide the name of the image. So here we want to get to this image, so we will go for sample underscore data, the root directory, and inside that we have to go for elon-1.jpg. Next, what it will do, it will actually provide us with the image, and next thing we have to actually convert this image from BGR to RGB. So there are different channels of color channels. I'm not going in depth, but the usual convention is that after reading the image, we just eliminate the unwanted channels. So here let's just go for Elon Musk and Elon image, and here we have to go for using cv2.cvt color, and inside that we have to provide this Elon image, the image that we just read, and then we have to go for cv2.color underscore BGR to RGB. Then we get this image, and if we go for CV2 IMShow, and inside that we provide this image, hopefully we will get the image. See, we get this image. Next is we have to identify the face, and then we have to get the encodings for that face. So for that we have to go for the face location, for getting the face location, and it will provide us with the coordinates of the face so that we can look for the face. We can just put a marker around the face. That's an optional step, you can ignore it. So what I'm saying is that we can directly go for getting the encodings of this face, that what is the difference between the eyes, what's the height of nose, what's the difference between two ears, eyes and ears, all that stuff. So the first way is we can directly go for getting the encodings. The other way is that we get the firstly that where is the face, and then we make sure that our program is actually identifying the face correctly so that we can move for getting the encoding. So we will go for the other way. We will look for the face. First we will identify and make sure that we are getting the face correctly, and then we will go for finding their encodings. So for getting the face, we have to go for face location. Let's just put it inside this. equals to face recognition, and inside that we have to go for face locations, and inside that we have to provide the name of the image of which we want to get the face location. So here provide this over here, and then let's just display face location. So here it is providing us the coordinates of the rectangle where the face is, and now we can just use this simple OpenCV method for figuring out, for actually portraying a rectangle on this face, so that we are sure that our program, our code is identifying the face correctly. So for that we have to go for CV2 dot rectangle, because we want to create a rectangle, and inside that we have to provide the image on which we want to draw the rectangle, this image, and inside this image we will then go for providing the coordinates, and we go for face location. The third point, let me just write this first, and then I will explain you that what I'm writing over here. And then the 0, then the next tuple, is basically 1 and 2. After getting 1 and 2, let's just put the colors. Let's just put some parrot green color of this rectangle, 255 and 0, and for the thickness let's just put 5. Now what this code is doing, that this code is actually considering this image that we are displaying over here, then it is identifying that where the face is, and then this we are getting the coordinates of the rectangle that will provide us the where the face is, and then we are just displaying it, or we are portraying our rectangle on inside this face. So if we just give it a go by copying the same line from here and printing it, I guess there is a typo, so let's just rectangle. Yeah, okay. So here this face location, when we actually saw that, we get it as a list. So we have to just go for the 0th for extracting the tuple out, and then we can provide the indexing. Now if we run that, so it actually uniquely identified the image, and then it identified the face inside the image, and then it just drew the rectangle around that image. Next thing is, after getting all the information of the face, that what are the coordinates for the face, and after portraying a triangle, next thing is, although this is an optional step, you can just skip it. I'm just doing that to show you that our code is working fine and we are successfully getting the face. Next thing is, we have to get the main thing, which actually is the encoding of the face. So for that we have to go for, let's just make it, the variable convention that we are using is alon image. So here we can go for alon encoding, and the alon encoding will go for face recognition, and inside that we have to go for face encoding, and we have to provide the image, which is alon image. And then if we go for displaying this, now under the hood it is definitely using this face location for identifying where the face is, and then it is extracting all these informations out of it. So if we go for 0 for dereferencing it to get the list instead of a list of elements, so there will be no difference, but we can directly use this. So we get the encodings of the Elon Musk face, and this is the pretty much information that we are looking for, that for the Elon Musk image we get the encodings and we get the feature scores of all the features of the Elon Musk face. Next thing is, we will try to now read another image. Let's say we'll read this test image for Elon 2, and then we will try to make it compare with this one. So we will be repeating the same thing again. So let's just copy it from here and move further. So we will be using this code for reading the image, and then we just need to show that as well. So here we are reading this too. Let's just make it, instead of alone image, let's just make it test image, because it's a test image. And we put it over here, we put it over here, and we put it over here. Now if we run that, you will notice that it will read the image and it will just simply print out the image over here. Perfect. Next thing we have to do is we have to identify the face, although again we can ignore this stuff, but still it's nice to do some nice to actually play around with this all stuff. So next we have to consider this test image, and actually let's just skip this part and put the complete code from bottom to the up cell. Now we want to get the face location for the test image, and here we want to apply the image or apply the triangle on this test image, and then we want to show the test image. Now if we run that, so it identified the face, and then over here we are getting the rectangle on that face. Next thing is we have to get the features, or we have to get the encodings of that face. So let's just comment this out again, and here, okay, let's just display that. We don't really have to uncomment this. So for getting the encoding, we have to copy this code from here and put it over here, and we just mark it as, instead of test image, let's just put it over here instead of alone image. And this is not now alone encoding, this is now test encoding. So let's just make it test encoding over here and test encoding over here. And now when we display it, you will notice that we are getting some encodings of the new image, of the second image of the alone. Now if you try to compare them manually, you cannot actually compare it because there is some complexity available. So for that, we go for applying the SVM to compare the two faces, and for that, let's just put this and put this inside the SVM algorithm for getting that whether the two images are same or not. So for that, we have to go for face recognition again, then go for compare faces, and inside that we have to provide the list of faces that we have, and right now we only have one face for comparing, so we just go for providing this one, the actual data that we have. So the thing is that if we have multiple images of alone, we will just put a list of all the encodings of the face just like that, and then it will actually provide us with much more better results. But right now we are good with the one, so we are just using the one. So we are getting the alone encoding, and then in the next parameter we will provide the encoding of the image that we want to compare. So we have this one, and then if we go for the face recognition and go for save it value in matched, let me just dereference it because it will provide us with the list. So we just need to get the actual value, and hopefully we will be getting true. Yes, we are getting true because both of these images are same. Next is for cross verify. If instead of alone we go for Donald and -1, and now again it will just look for the Donald image, and we can actually uncomment this as well. Now it will just look for all the encodings of the Donald Trump face, and it will compare it with the Elon Musk, and most probably we will be getting the false because they actually don't really have any similarity. So it identified the Donald face, and here we are getting the false. So that means that both of these images are not, the person inside these images are not same. Now further we can actually print this all matched and all this fancy stuff inside in a multiple way, in a multiple fashion. We can put it in an image, or we can do further processing or further playing around with that. But this is pretty much it from this video. We developed the understanding of how it's working under the hood, and then we just saw some simple code. I hope that you enjoyed working it. I hope that you grabbed the idea, and still if you have any questions, any concerns, please feel free to let us know in the comment section, and we will try to get back to you on that as soon as possible. Also, please do hit the bell icon and do subscribe to our channel so that you get the notifications of our new videos. So this is pretty much it from this video. I will see you in the next one.